Welcome to Mastering Solutions. This problem is taking the previous question and taking it just a step further. So let's start off by listing the n, or the index of refraction, for a few different variables. So n of water is going to be 1.33. These are found in the book, but I'm going to put them here just so we have it for a reference. N of glass is 1.50, and the n of a diamond is going to be 2.42. So this is very similar to the previous question that we did. And what we're using is the velocity equation, which is the change in a distance over the change in time. And we're just rearranging it to solve for time, which of course is going to be t is equal to delta x over v. We've done that a million times at this point in the book so far. And now we need to use the velocity of light, but it's the velocity of light in a certain medium. And that comes from the equation for the index of refraction itself. So the index of refraction is equal to c, or the speed of light in a vacuum, over the speed in a certain medium. And then we rearrange this so that the speed of light is equal to c divided by the index of refraction. So we're going to use this and this to solve for all of these different things. For part A, in a vacuum, vacuum, speed of light in a vacuum is going to be equal to the time, and we're going to use this, which is the change in the distance over the velocity, but we're going to plug this equation in for the velocity down here. So that's going to be c divided by n. Now, since we're in a vacuum, of course, the n is going to be 1, meaning that the c, or the speed of light, is the speed in a vacuum. So we could rearrange that or simplify it if we wanted to as the distance divided by c. They want to know 1 meter, so 1 meter divided by 3 times 10 to the 8 meters per second. So we have meters divided by meters per second, which is going to cancel the meters and leave us with seconds. So we know that we did the equation right. So if we plug this into our calculator, we have 1 divided by 3 times 10 to the 8th gives us 0, 0, 0, 0, a lot of 3s. So let's change this just so that we make sure we don't do error by counting them wrong, and put it in scientific mode. And then if we do second answer, that gives us 3.33 times 10 to the negative 9, or 3.33 nanoseconds. 3 times 10 to the negative 9 seconds, which is 3.33 nanoseconds. So that's the answer for part A. One thing that I really enjoy about this calculator is they have a lot of standard units plugged in, so you don't have to worry if you can't remember something. It's helpful on a test if you get stuck. So you go 1, and then we're going to divide that by second, and we're going to go over to constants right here. And now number 1 right there, speed of light c. So 1 divided by c gives us 3.33 times 10 to the negative 9. Now, the reason this is a little different is because this c is going to be more precise than the rounded, simplified version that our textbook uses. So now we just need to do the exact same thing. We need to figure out how far is it traveling in water, glass, and diamond for that time. So we have the 3.33 nanoseconds. So we're going to use the same equation here, but now we're just going to rearrange it to figure out the distance. So we have velocity is equal to the change in distance over a change in time. So if we multiply both sides by t, we have x, or the change in the distance, is equal to the velocity times the time, of course. So let's start off with the first one. They say water. So we have the velocity here. We do need to use the same one, cn. So let's simplify this even more. So we have c over n times the time. And so for water, we're going to have, I'm just going to use c, so you don't have to see me write this over and over, divided by the n of water, which we wrote at the top is 1.33. And then we're going to multiply that by the answer, 3.33 nanoseconds, or 10 to the negative 9. So we have 3 times 10 to the 8 times 10 to the 8 divided by 1.33. And then we're going to multiply that by our answer, 3.33 nanoseconds, or 10 to the negative 9, which gives us an answer for the distance in water is, let's go back out of this. I like normal mode. Okay, so we have 0.75 meters. So that is going right here, 0.75 meters for how far it went for that time period if it was going in water. Let's give us a little bit more room here. Okay, so now let's do glass. So we have glass is going to be equal to C divided by 1.5 for the index of refraction of glass times 3.33 nanoseconds. And if we go to our calculator, we can just take the same thing and we're basically just changing the index of refraction. That's all we're changing. So 50, and that gives us 0.66. We'll round that to 0.67. So we have 0.67 meters for glass. And then last one is we had the diamond. So the diamond is going to be C divided by 2.42 for its index of refraction. And of course the same time, nanoseconds. And so let's go right here. And we have our index of refraction instead of 1.5, we have 2.42. And that gives us 0.41 meters. So 0.41 meters. So you can see that the higher the index of refraction goes, the slower the speed of light is going in that medium. So it's going to go the least far in the diamond. It's going to go, the middle option, of course, is a glass, and it's going to go the farthest in the water, and of course, the furthest in a vacuum.